Hey, welcome back. This is Unit 10 in Algebra 2. This lesson 2, is a little bit more about simplifying expressions with exponents. We're going to begin with a review from Lesson 1 mainly, and with perhaps a few more challenging things thrown in. And then we're going to expand that to look at what happens with rational exponents and our properties of exponents. So let's get going. All right, we're going to simplify some expressions. So we looked at some in the last lesson. These are just going to be probably a little bit more involved, but mainly the same thing. So I will multiply the coefficients 5 and 2, and x cubed times x to the negative 6 is x to the negative third. Y to the second, y to the third is y to the fifth, and then z times z is z squared. You may be wondering why we're just multiplying, we're not foiling or doing anything like that. Just keep the reason why is there's no pluses. If there were pluses in between there, this would be totally different and much more difficult. But these are each just monomials. All right, so this becomes 10y to the fifth, z to the second over x cubed. All right, let's take a look at the next one. All right, 3 goes in the 3 and 9. 3 goes in 3 one times and 9 3 times. And 2 and 2 can reduce. So I like to reduce the whole numbers if I can before I multiply. But I don't want to get too crazy with trying to reduce these letters. If they perfectly cancel, I might go ahead and do it. Anything on top I can reduce with anything on bottom multiplication problem. So I can go ahead and reduce the z's. But I don't want to start trying to change the y to y cubed or things like that, because it starts getting difficult to read. So now this is where I'm going to rewrite. I have a 3 on top, I have an x, I have a y to the fourth, and I have another x. Then on bottom, I have an x to the fifth and a y. So I may not have even reduced the z's sometimes, but I did see that those perfectly canceled. All right, now we'll start doing our process. On top, I've got 3x squared y to the fourth over x to the fifth y. And I got 2 x's to cancel out with the 5 x's on bottom, so the x's on bottom become x to the third. And 1 y on bottom cancels with 1 y on top, giving me y to the third on top. All right, on the next one, we should be using keep, change, flip here. So keep the first fraction the same. Change division to multiplication, and flip. All right, and then we will reduce. 5 goes into 5 once and 10 twice. And then I'll go ahead and just multiply out. 5x cubed yx over 2x times 2y squared. All right, I do have a perfect cancel here and here. So I'll do that. So this becomes 5x cubed y over 4y squared. And lastly, I've got 1y on top that can cancel from 1y on bottom, making it 5x cubed over 4y. You just want to be careful when you're doing these. Don't try and do too many steps at once, because you cross things out and start changing the little exponents. Pretty soon, you can't read your handwriting. So just be careful. All right, on this next one, I've got a negative number, but on the outside of the parentheses is an even power, so that's just going to become positive. 3 squared is 9, and then we power to power, we multiply x to the 6th and y to the 10th. And on the next one, I've got a negative number inside parentheses, but to an odd power. So it's actually going to stay negative. So this will be negative 8, a to the 12th, b to the negative third. And I've asked you to rewrite where there's no negative exponents. Not that it's better, just it's good practice to know how to handle that and what it means. So if you would please work these practice problems, practice 2.1, and then we'll go over it. All right, let's see how you did. All right, you should have multiplied these and got negative 20, p to the negative 1, q to the second, and then r. You got to mind your p's and q's on this one, though, don't you? Negative 20 q squared r over p to the first. Don't move to negative 20. It's fine. It's got an exponent of positive 1. All right, on this next one, I think we can reduce. I'll reduce the whole numbers, the coefficients first. I could do that. All right, 3 goes in 6 twice and 9 3 times. That's not too bad. And then I'll go ahead and move forward. 2 times 2 is 4. X to the negative 2, z to the third, over 15. X to the negative 2, y to the fifth, and then there was a z. All right, I think that looks pretty good. So it turns out that these x's actually perfectly cancel out, don't they? So I'll go ahead and do that. So this is 4z, the z cubed over z becomes z to the second, over 15y to the fifth. All right, next question. Keep, change, flip here. All right, the 5 and the 15 reduce to 1 and 3. B and B reduce, and C reduce. So I've got 2A on top and just 21 on bottom. Okay, on the next one. Again, you could just write this as 1 over right now. You could do it just like this if you prefer. Just move everything to the bottom. But I think most of my students prefer to just apply the exponent to each factor. So this is 7 to the negative 2, x to the negative 6, y to the positive 4, z to the negative 2, and then I'll move everything. Y to the fourth, everything else is going down. 7 squared, x to the sixth, z to the second. So y to the fourth over 49, x to the sixth, z to the second. Okay, now in this next one, I really need to simplify these two things first and then combine them. So that's a negative, but to an even power, so it's positive. So this is 16a to the fourth times a to the second, b to the negative 6, which becomes 16a to the sixth, b to the negative 6, which becomes that. All right, let's take a look at example 2.2. We're going to rewrite each of the following expressions using radicals. So that's how this works out. 5 times the square root of x times the cube root of y squared. On the next one, it's 1 over the square root of 3x, because that is a negative in front of the 1/2. All right, now we can do the reverse. We can rewrite these using rational exponents. So since the entire 5a squared is under the cube root expression, I put it like that, and then the 1/3 power. And then this becomes 2/3 times x to the 1/2. On the x to the 1/2 is the denominator, excuse me. So 2 over 3x to the 1/2. All right, let's practice evaluating some simple expressions again. 16 to the 3/4. I'll take the fourth root of 16, which is 2, and cube it. Remember to do the root first. And 2 cubed is 8. 5 to the negative 2 is 1 over 5 squared, which is 1 over 25. 3 to the 0 is 1. And negative 4 to the 1/2 power is no solution, or non-real, because you can't take the square root of a negative number. 4 to the negative 1/2, though, is quite easily done, because that's just the square root of 4 in the denominator. So big difference between D and E. All right, go ahead and practice doing those. Pause the video, take your time, and then we'll go over it. Okay, 27 to the 4/3 is 3 to the 4th. So cube root 27. Now 3 to the 4th is 81. The negative does not get the squared, so this is negative 9 because it's not in parentheses. This is 1 over 4 to the 3/2. The square root of 4 is 2, and 2 cubed is 8. 9 to the 1/2 is the square root of 9, which is 3. 3 to the 0 is 1. 5 to the 0 is 1, and 1 plus 1 is 2. 5 to the negative 2 is 1 over 5 squared, which is 1 over 25. All right, so now we're going to simplify some expressions that have rational exponents. The rules are the same. You just got to be careful. So I've got 2 times 5 is 10, and now I've got to add the exponents on x. So just do some scratch work. 3 halves plus 1 half. Well, these already have a common denominator. So you add the numerators, and the denominator stays the same. So the answer is 2. So this is 10x squared. Now I do the y's. I have to add 1/3 plus 1 half. Okay, well, they don't have a common denominator. No big deal. I just multiply by 2 over 2 on this one and 3 over 3 on this one. So it's 2/6 plus 3/6. Once I got a common denominator, remember the denominator stays the same. You just add the numerators. 2 plus 3 is 5. So this is y to the 5/6. All right, we can also do some division problems like this. I'm going to reduce these by 2, so this is 4/3. And I am going to go ahead and continue moving negative exponents before I start combining stuff. All right, so a to the 2/3 times a to the second. We need to add 2/3 and 2. All right, so 2/3 plus 2, that's 2 over 1. So I'll multiply it by 3 over 3. And I get 2/3 plus 6/3 is 8/3. So this is 4a to the 8/3. Now we got to subtract the exponents on b. So 3 minus 5 halves. 3 over 1, I'm going to multiply it by 2 over 2. So 6 over 2 minus 5 over 2 is 1 over 2. And since 3 is bigger than 5 halves, it's on top. Or you could think of it because we got a positive exponent, so it's 1/2 on top. All right, on the next one, again, same thing, power to power, you multiply. 2 squared is 4. 5 halves times 2 just reduces to 5. 1/4 times 2 reduces to 1/2. Let's take a look at the next one. Okay, again, power to power, we multiply. Yes, I've got a negative, but look at the top of this fraction. It's an even number, so this is going to become positive. The cube root of 27 is 3, and 3 squared is 9. Now I've got to do 2/5 times 2/3. Multiply top time. There's nothing to reduce, so 2 times 2 is 4, 5 times 3 is 15. So 4/15. And then this becomes b to the, this is a negative 1/4 times 2/3. Reduce, negative 1/6. So I have 9a to the 4/15 over b to the 1/6. Okay, looks like you've got practice problem 2.3, so please pause the video and give it a try. All right. Here we go. Let's see what we got here. We got 12 to the 1/2 times 3 to the 1/2. And as we mentioned, you can actually multiply the bases whenever the exponents are the same, but just keep them the same. So 12 times 3 is 36 to the 1/2. But that just equals 6. So 6x. Now we got to add the exponents on x. 4/3 plus 3 halves. This becomes 8/6 plus 9/6 is 17/6. Then y to the 1/3 times y to the negative 4/3 is negative 3/3. So 1 minus 4 is negative 3. So it's just a negative 1. So our final answer is 6x to the 17/6 over y. All right, on the next one, we reduce 12 and 9 by 3, giving you 4 over 3. So this is 4a to the 5/4. I'll go ahead and move this a up. And I will move the negative 2 up as well. And all I'm left on the bottom is a 3. So 4a 5/4 plus 1/4 is 6/4, which is 3 halves. And then this becomes b to the 4th over 3. All right. power to power. So 9 squared is 81. 7 halves times 2 is just 7. 3/8 times 2 is a negative 3/4. So this becomes 81a to the 7th over b to the 3/4. All right, we have a negative again, but look at the numerator on the power. It's even, so it becomes positive. So this is x to the 5 times 2/3. 5 times 2 is 10, so 10/3. And then this becomes y to the 6 over 12 is 1/2. All right, now on this one here, we have a little bit to do here, actually. X to the 1/2, y to the 1/3 times 4x, and I'll bring this negative exponent up. All right, so when we add this, we'll get x to the 3/2. 1/3 plus 3/2 is I'm tired of doing this in my head. Let's do that. So this becomes 2/6, and this becomes 9/6, so it's 11/6. 11/6, and on the denominator we have just a 6. All right. Okay, the exit ticket here is also kind of fun. It says, which of the following statements are true? And explain. We'll just explain out loud. Hint, only 4 of them are true. So here's the question. If I have 2 cubed times 2 to the 5th, does that equal 2 to the 8th? Well, yeah, it does, because the bases are the same, so I can add the powers. What about this? 2 to the 3rd and 2 to the 5th, does that equal 4 to the 8th? Well, no, it doesn't. You cannot multiply bases that have different exponents. It does not work. So that is wrong. What about this one? 3 to the 3rd times 5 to the 3rd. Does that equal 15 to the 6th? No, because you can't multiply the bases and add the exponents. This would actually equal 15 to the 3rd. What about the next one? 3 to the 3rd times 5 to the 3rd. Does that equal 8 to the 3rd? Close. They have the same exponent, so we can multiply them, but it should be equal 15 to the 3rd, not 8 to the 3rd. How about this one? Okay, they have the same powers, so we can multiply the bases, but the power stays the same. On the next 3, they're all the same problem, done in a variety of different ways. 4 to the 5th times 4 to the 5th. So as we've already seen, if the bases are the same, like a squared times a cubed, you can multiply, you just add the powers. But we've also seen that if the powers are the same, like both the power of a, you can keep the power the same and multiply the bases. So if in the unlikely situation where I have the exact same base, the exact same power times itself, I have the option of adding the exponents or multiplying the bases. So this works because they added the exponents. This works because they multiplied the bases. This is wrong because they tried to do both. And that's it for this lesson. I will see you in the next one.